I may perhaps take some limits to repeat that. This is this evening's talk, microsatellite SSS-1 and its orbit test result. I'm from Beihang University and the Regional Center for Space Science and Education in Asia Pacific. Our regional center actually now just show this slide, now have 10 member states located in Asia, Africa, and South. So ours located in China. And this is established in 2014. And last year is our 10 years anniversary ceremony, 10-year anniversary ceremony. So this is 11 years for our regional center. This century, we actually including two kinds of training program. One is normally degree education, including master and doctor degree. And actually in this semester, one of another education we could just call the education century. Perhaps later it will merge in our regional center. We are beginning for the bachelor degree. Other parts we just for the training program, including like summer school and the training program, or just some serious courses or some exchange student program like that. So we mainly focused on the space technology related, actually application related direction, including remote sensing and geographic information system, then satellite communication and global navigation and satellite system, then microsatellite technology, space law, space science and environment, space project management. Actually, space law now still located in Beijing. Now ours, it's others mainly move to Hangzhou campus. This is the new campus of Beihang University. We are totally, in this 10 years, we have almost 400 students from 27 countries got the master degree or doctor degree. And some like the training program, we are take a lot of such kind of short-term training. We are such kind of training. We are also make the cooperation with our industry department and some other universities so come together. Now almost like near that like the 2,000 participants from more than 70 countries join such kind of training program. So we have a lot of some like the facility or some like the resource. This is the regional center is supported by our country's aerospace industry department. So we can let the student to join some like the some others organizations activity, or even we have some like joint training program, and also let the student moving and visit the different kind of aerospace related facility or organization. So we have lots of cooperation partners in China, this country, and especially recent years we have lots of we call the commercial aerospace company now just set up. So this is also China government issue such kind of program from 2015. So this year is 10 years, 10th year. So we are this year part is also developed very quickly. So this year, the spring, because we are belong to the United Nations outer space, some like some department. So because this year is our 10 years established this century. So lot of officials from United Nations make the inspection for our regional center. The reaction is quite good. And this is this semester. So this picture is just in last month we take the picture. This is almost including the total new coming student from our member states, all out of our member states, around like the 70 student this year. So this is, I just give you very briefly to introduce our regional center. I also worked for this regional center, especially for this year or even next year. I mainly time should work for this regional center. Okay, now I begin to this evening's talk, microsatellite SSS-1. So, you know, usually we told like the small satellite, microsatellite, nanosatellite or something. Actually, in China, all the satellite below than 1 ton or 1,000 kilograms, we call the small satellite. Others, we maybe should divide it more. For example, less than 500 kilograms from more than 100 kilograms, we call the minisat. Then microsat, it's just the 10 to 100 kilograms. And then nanosat, it's 1 to 10 kilograms, even more, even smaller, like the picosat. That is less than 1 kilogram. So usually, some like microsatellite, nanosatellite, or more smaller satellite, we are just suppose they are suitable for some university or college or some small research institute to development for special kind of research or verification purpose. So some faculties told it is a very efficient way for students to study and develop space technology through special micro-nano satellite project. So in such kind of background, ABSCO, Asia Pacific Space Cooperation Organization, launched the student small satellite. Oh, this is very easy to remember. SSS, student small satellite. This is just the logo our student to design for this project. So what is SSS project? SSS project actually it's including 3 satellites, including 1 microsatellite we call the SSS-1. It's around 30 kilograms, and others is 2 3U CubeSat around 4 kilograms. So this is just launched by ABSCO. So we are called ABSCO Student Small Satellite. Beihang University, after some competition or some make the proposal discussion, we are the leading university. But actually, this is also should through the international cooperation. Then we developed the project. Actually, Iran University and also some professors like the Professor Mishan from Iran University, and also it's one professor, Professor Safavi, it's from Amirkabir University in Iran. So also as a subject leading to support this project. This project is also right in the China's government white paper, China Space Activity 2016. And what is the missions or mission tasks of SSS-1? Because Beihang University mainly for SSS-1, it's a microsatellite. So this evening I just mainly focused on this project, this satellite, microsatellite. The microsatellite or small satellite, the development, very important, is just should talk about their missions. So one of the missions is we just try to conduct the coilable mass deployment in space, just like that. The satellite, it's launched in space, just like the left side. Then in the space should deploy the long coilable mast. And others, we call intersat communication, because we have a 3 satellite, so we can send some signal from the microsatellite to the CubeSat, or CubeSat send some message, microsatellite receive. So this is a very simple intersat communication. Then third one is we call the satellite-based ADS-B test. You know, ADS-B actually just the special kind of passenger message. It's sent by the passenger plane when they fly, so that the ground station or airport know their situation of the passenger. But this is usually the signal should be received by ground radar or some ground station. But such kind of coverage, it's not all the surface of the world. Even for China, you can find the red one is just such kind of radar or ground station coverage. So then we can receive the signal. But others could be sometimes it's difficult to receive the signal. So you also maybe can heard like the story of Malaysia, some passenger plane missing. So we just try let the ADS-B put on the satellite, so that try let the satellite such kind of receiver receive such kind ADS-B signal. So this is we would like to test in our microsat. Then this is the normal. Take the picture for the Earth or something. It's then transform this picture back to the ground like that, and also have tested some like the new type of our special kind of components, like electrical propulsion system or some special kind of optical fiber gyro, something like that. So this is it's from 2016 end December, very late. So we used almost 5 years to finish this project. So what's the very important key technology? One is just we call the coilable mass deployment. This is just some video you can see in the lab. It can layer by layer to step by step to deploy. You can find in such kind of way. After they deployed, they just provide the stiffness. So such kind of deployment, it's very very stable. This is we are also published some papers because in such kind we are specially provide some boundary condition. It can deploy like such kind of stable style. Then we conducted such kind of design and let the student join and conduct the physical test and the simulation like that. Second one we call the structure optimization. This is just like the structure, let the satellite structure, the weight of them as low as possible. On the other hand, it should satisfy some like any kind of responses or the stress or the strength or some like deformation. This is just we are conducting the calculation. FEM, then use special kind of software, conduct the optimization. And the third one is a special kind of attitude control, because our satellite is quite special because the coilable mass still very flexible. So it will affect their attitude. So we should develop a special kind of attitude control method so that it can got very good accuracy for such kind of attitude control. Then we are also use the Wi-Fi facility to conduct the intersat communication and also download the data from the satellite to the ground station. Just use the Wi-Fi frequency. So it's just like our satellite. It's a hot point in orbit 500 kilometers away. So we are also conducted some like the special technology test, like electrical thrust test. So this is just the project, some special kind of missions and special key technology. This project still through, we are follow fairly normal steps like the PDR, CDR, engineering model test, flight model test, and some like AIT, and then launch. It's just to follow our industry steps. So it just for some like the education, let the student through such kind of project then running the space technology. So we are also conducted some like we call the education activities, like 3 times of a summer school. Maybe some it's in one year it's in Beihang University, others in Toosi, Middle East Technical University. We are also conducted the online education. Let the international student conduct the presentation and let our test show all other member states team. Then this is some like the we call the engineering or flight model test. This is a table test. Just to put some like the facility, subsystem or components or equipment together. Then just like the whole the satellite put on the desk. In this desk, it's just like our satellite, so that we can use the command compute special command just simulate the ground station, send a different kind of command, let the satellite how they works. If some problem, we can make some adjust, something like it. This is we call the desk joint test. So after such kind of test, then we conduct some like the assembly. This is just a design, how we conducted the assembly. After that, we just put some like the structure, and then the components in assembly together. So this is just like such kind of procedure. So after that, we are also conduct some antenna. We are also have some like the this is a vibration test. Our satellite, you can see, yeah, this is a vibrate. This is the finally. Oh, sorry. Yeah, put us the vibrate. We can find it. It's some like sensors put on the surface, so that then we can find that they can put on the vibrate or shaken them, so that in different direction. This is we call the vibration test. In the right side, we are also have some like different test. This is we call the separation. This separation is just like you can find the separation system put on. This is just like we if the satellite we are just separated from the launch vehicle. Here it's also we have some like antenna deployment. Then we are also conducted some like coilable mass deployed. Yeah, this is because after the vacuum test, we should verify any of our deployable mechanism still can work. So this is just like some like the very important test. So we should got more. This is finally we can deploy it like that. Yeah. So this is we have conducted some like the vacuum test. After vacuum test, we are also conducted, we call the EMC test. This is mainly just simulate the ground station and the communication with the satellite. Table test, table test. We are just use the cable to use the computer send the signal through cable. But this is just like simulated only 1.5 meter. But this is we are simulate the distance just like the ground station make the communication with the satellite. So this is special kind of device. We have lots of some resistant so that simulate the 500 kilometers. And the right, it's just a special kind of facility. This is we conducted the test in CAST. This is a big building. This is just to simulate the Earth's magnetic field. So that because we are in the attitude control inside, one of the actuate is a coil, it's a magnetic torque. So we need such kind of test so that we can to verify our attitude control method and some like the physical parts could be work properly. So after that, then the satellite could be departed to move to the launch site. So this is just we are departure from our university. So one of the vice secretary general of ABSCO and our president, university president, also come here to make this ceremony. And our student leaders and our student team and the faculty team, we are together. So we are set up for the launch site. This is our satellite in the launch site and put on the launch vehicle. You can find the left, the right hand, we are just in the middle, our satellite. The top is the bigger one. Bigger one is the main set. So this is just like inside of the fairing. After that, we put on the fairing, our satellite put inside of this launch vehicle. So this is we are just Shanghai Jiaotong University. They are in charge of S2A. We are S1. Unfortunately, Turkey's S2B, they are delayed to launch from other side. It's not joining us together. So ours, it's inside of the fairing. We are also very proudly, you can find the ABSCO, the logo, it's put on the fairing. And the others, it's the main set. It's just the China's industry, aerospace industry. So in October 14, 2021, we are launched. So now we just show you some like the result in orbit. Sorry, the time is very intensive. So this is we are just the facility, very simple. Just we can receive some signal. We are also have some like the ground station. We are high from our commercial companies. They support us download some signal and the data. So we have this is the only one ground station. It can receive the signal of our data, because the data is Wi-Fi frequency. So we just move to this ground station to Anhui province, countryside. There it's lot less some like the signal of Wi-Fi disturbance. If we in the urban area, we even cannot receive the signal because our ground, our satellite, the signal is quite weak. If you compare some like the urban or cell phone or something, as Wi-Fi, they have lots of disturbance. So this is just our data to download. This is just the below it's just the data. Others is the picture. This picture is it's from our just the bottom of coilable mass, so you can find that. If we can find, because we have the top, the bottom of, or the top of satellite body in the blue side, blue and green. Some area we have the camera. So take the picture like every second, several seconds, they can take the picture. It means our coilable mass successfully to deployed. Some of the data in the right side we also can find. This is almost immediately we know, but the picture is 2 days later we decode it so that we can got the picture, something like that. So that is successfully show us we are successfully deployed our coilable mass. Then this is a ADS-B signal we are got. You can find the right up side. It's just our satellite go through the United States, some like ground. So each of the red points, it's just the passenger plane from where to where. There is some like the information, the flight number or their velocity or toward the direction or some like the other information they can provide by the ADS-B information or data. They have the special kind of format, so we can use the software decode the received signal, so can show that like such kind of show the screen. And this is just the interset communication between SSS-2A and our satellite SSS-1. Some like send the signal, receive the signal, then checked by our 2 satellite team. And this is just some like the pictures taken from our satellite toward the Earth. Then different position on the Earth. This is some show you some like pictures. Just use Wi-Fi frequency download the picture. Then after that, we try conduct the attitude control. So you can find our picture, our camera. We have the 2 kinds of camera. One is on the top, just watch for the coilable mass. Others is toward to the Earth. So now we change our attitude so that we can take the picture to find the horizontal of the Earth, so that you can see half is Earth, half is the space. So you can take the picture like the left hand below. And also this picture, it means our satellite up down. Yeah, originally the coilable mass is toward to the deep space. Now we just let them to up down so that it can toward the Earth, something like that. Then this is just try to find the moon. So we let the attitude or the coilable mass try find the moon. It's unfortunately the moon originally quite small. So this is just our some test for some electrical propulsion system, some like the data. And this is just some like the half year, some like the temperature change, the power change, or the attitude angle, some changes. This is just like some like the orbit information change. This is just thermal in different area. Different position, we have the sensor. So we have a lot of data in some like the 700 days. We have some different kind of data and accumulated. So this is just got the data. We try the figure. Totally, we have some like got a lot of pictures, send a lot of command and download lot of information. This is just our satellite in orbit, some performance. This is show the designed missions. We are all of them. We are very successfully to realize and got some like the information. This is just we take the pictures, then try conduct the processing to build the video, something like it. In the left is our in-lab deployment of colloidal mass, and the left it's just the in space, something like that. Okay, so much for my presentation for this evening. Because time now, I think maybe it's more 10 minutes, sorry. Thank you. Okay. Yes, I talk. It's finished. If you have any kind of questions or something need to talk with me, it's welcome. If you have any questions or problems, it's also are welcome to feedback to me. And yeah, it depends you what kind of later. I do not know how you arrange the late time.
سلام، وقتتون بخیر. خیلی ممنون از ارائه خوب و ارزشمندتون. خواستم سوال بپرسم که نظرتون راجع به ادامه کار توسط دیجیتال توین چیه؟ خیلی متشکرم.
Yes. Continue for this project, you mean? This project, I suppose, is we are generally say our student, yeah, it's some like the student now, almost all the student now is graduated to join the industrial department. Only some very few of them now continually to study for their some it's for PhD degree. It's also because we launched the satellite in the late of 2021, and in the orbit we almost make the orbit operation until to the 2024. So that after that, it's some like the lifetime or some like the component it cannot work, and the orbit it's lower and lower until to this year's end of May or July they will deorbit. So this project we suppose is finished, but now we are continually for launch other some like the still especially for student organized, then developed the satellite. Recently, we signed the cooperation contract with Mohammad University in Thailand. So just 2 weeks ago, 1 week or 2 weeks ago, we can sign. But some of the work early, maybe half a year, we begin to start. So this is we are just for another kind of satellite. And besides that, our students also, once we are joined to the local government launch the satellite, but this is not in charge by Beihang University. Beihang University, just like our team, our student microsatellite team and the faculty join their local government launch the satellite. We are making the call